Hello everyone, welcome back to my channel. In this video, we gonna discuss solutions of NAD and semester exams. Let's start. Question number 1. Find the roots of polynomial x square minus x minus 1 through fixed point iteration method. Also make a table for the various possible equations and show their nature whether they are convergent or divergent in nature. Let's take assumptions. Function f of x is equal to x square minus x minus 1 and function f of 1 will give negative value and function f of 2 will give positive value. Hence root is between point x is equal to 1 and x equal to 2. So we can take x0 is equal to 1.5 as median value. Let the function f of x equal to x square minus x minus 1. Here are the following equation g of x that can be made through f of x. In this table, we have four equations of g of x. Now differentiate each g of x and then put the values of x as 1 and then 2 in all the g dash x respectively. Check whether the value is greater than or less than 1. For the selection of correct gx, mod g dash x should be less than 1 and if multiple value of g of x are less than 1, then choose the least one. Table for the conversions are follow. After finding the values of g dash x on the putting x as 1 and then if we get the value less than 1 for both the values of x, then the graph of that g of x is convergent and for all other conditions the graph will be divergent. The maximum number of iteration I is reached. The method did not converge, exist a loop. If the solution converged, output x of I as the approximate root of f of x equal to 0. Otherwise, output an error message indicating that the method did not converge. The choice of the function g of x depend on the problem. In this case, we can rewrite the equation f of x equal to x square x minus 1 equal to 0 as x equal to g of x and solve for g of x to obtain the iterative equation. Part B, write an algorithm for finding the root of f of x equal to x square minus x minus 1 equal to 0 using the fixed point iteration method. First, to find the root of the function f of x equal to x square minus x minus 1 equal to 0, we can use the fixed point iteration method with an appropriate iterative equation. Here's an algorithm that outlines the process. First, start with an initial guess for the root. Let's call it x0. Set a convergence criterion such as a maximum number of iterations or a desired level of precision. Tolerance that is called tolerance. Initialize the iteration counter. Let's call it I to 0. Repeat the following steps until convergence of reaching the maximum number of iterations. A. Increment the iteration counter. 1 I is equal to 1 I plus 1. B. Compute the next iterate using the fixed point iteration formula. Xi equal to g of x I minus 1 where g of x is a function that transforms x. C. Check for the convergence. If mod xi minus xi minus 1 is less than tolerance, the solution has converged. Then exit the loop. Part C. Write the output of the algorithm of question 1, part B. The g of x equal to root x plus 1 should be taken for the fixed point iteration method. We'll take x0 is equal to 1.5 which is a median value. Then x1 is equal to root 1 plus 5 plus 1. The value of x1 will be 1.5 at 1 1 and we do the same with x2 x3 x4 x5 and x6 equal which give the value 1.6179 and x7 will give 1.618001 as the error between x7 and x6 is 0.000101. Hence root of x square minus x minus 1 is 1.618001. Question number 2. Write the algorithm for the Gauss elimination method with pivoting. We'll take an input, a system of linear equation represented by an augmented matrix A. Set the current pivot row to 1. For each column j from 1 to the number of columns in A minus 1, do the following. Find the row I, which is current row with the largest absolute value in column J, starting from the current pivot row. We swap the current pivot row with row I and see if the value in the pivot position of current row, which is J, is 0, continues to the next column. For each row I from the current pivot row plus 1 to the number of rows in A, do the following. A, calculate the multiplier M equal to A of I and J divide by A with current row and J, which is the ratio of the current element to the pivot element. B, for the column K, from J to the number of columns in A, update A of I and K minus, equal to A of I K minus M multiply by A current row and K. Set A of I and J to 0 to ensure numerical stability and elimination rounding errors. If the current pivot row is less than the number of rows in A, increment the current pivot row by 1 and go to the step 3. Otherwise, continue the next step. Back substitution, starting from the last row and working upwards, solve the unknowns. A, set each variable xn, where n is the number of columns in A, to a n plus 1 divide by A of n and n. B, for each row I from n minus 1 to 1, calculate xi is equal to A of I n plus 1 minus summation of A of I and k multiply by xk divide by A of I and I, where k goes from I plus 1 to n. Now part B. Find the solution of the system of equation using iterative method. 20a plus b minus 2c is equal to 17. 3a plus 20b minus c is equal to minus 18. And 2a minus 3b plus 20c is equal to 17. We find the value of a, b, c in the respective equation by taking variables from one side. Um, a is equal to 17 minus b plus 2c by 20. B is equal to minus 18 minus 3a plus c by 20, and c is equal to 17 minus 2a plus 3b divided by 20. Let a0, b0 and c0 is equal to 0. Then the value of a1 is equal to 0.85 and b1 is equal to 0.9 and c1 will be 0.85. We'll put this value in the equation and we'll get the value of a2, b2, c2 and a3, b3, c3, a4, b4, c4. We'll follow these steps till we get repeated approximate values. Part C, list out 4 disadvantages of Gauss elimination and 3 advantages of iterative methods over elimination methods. The iterative method is superior to the elimination method. We'll see advantage of iterative methods over elimination method, um, which is first, computational efforts is approximately 2n square arithmetic operation per iteration, and if convergence is achieved in less than n iterations, it is significantly superior compared to the elimination method. Second, another important advantage of the iterative method is the small rounding error, the rounding error being the one committed uh, in the last iteration. Thus, for ill-conditioned the system, an iterative method is a good choice. Third, in Gauss-Seidel method, we set xi equal to the newly calculated value of iterate stored in time. The disadvantage of elimination are as follow. First, computational efforts is approximately 2 and multiply by 3 divided by 3 arithmetic operation in each elimination step. Second, the amount of bookkeeping necessary is considerable. And third, the rounding error may become quite large, particularly for ill-conditioned equation. Fourth, any special structure in the matrix of coefficient is difficult to preserve during elimination. Question number 3, Part A. Obtain the estimate of the missing figures using delta and E operators in the following data, which is 2, 0.135, 2.1, space 2.2, 0.111, and 2.3, 0.1, and 2.4, space 2.5, 0.008, and 2.6, 0.007. Um, Here we have 5 values and their corresponding datas are given x1, y1, x2, y2 till x5 and y5, and we have to find out of data corresponding to the value 2.1 and 2.4. Here we use Lagrange's interpolation. So formula is y of x is equal to x minus x2, x minus x3, x minus x4, x minus x5 into y1 by x1 minus x2, x1 minus x3, and x1 minus x4, and x1 minus x5, plus x minus x1, x minus x3, and so on, into y2 divided by x2 minus x1, x2 minus x3, x2 minus x4, and so on, plus x1 minus x minus x1, x minus x2, and so on, into y3 divided by x3 minus x1, x3 minus x2, x3 minus x4, and so on. It will go to the y5 values. Then we use Lagrange's interpolation formula. Y of x is equal to x minus 2.2, x minus 2.3, x minus 2.5, and x minus 6 into 0.135 plus divided by 2 minus 2.0, 2 minus 2.3, 2 minus 2.5, 2 minus 2.6, and so on. Uh, um, we put the values of x and y in the Lagrange's interpolation formula, and uh, then we put x is equal to 2.4. On solving the above equation, after putting value of x is equal to 2.4 is y of 2.4 is equal to 0.008. Put x is equal to zero point 0.1, then it will give 0.21, 0.1218. These two are the missing uh, parts of the equation. Now part B. In an examination, the number of students who obtained marks between certain limits were as follow. You can see in the table the row 1 contains the range of marks and the row 2 contains number of students. We have to determine the number of students in case 1 who secured more than 48 but not more than 50 marks, and case 2 who secured less than 48 but not less than 45 marks. In this given table, we have marks and the number of students who scored different marks, such as number of students who scored less than 40 marks are 210, students who scored less than 45 marks are 253, and so on. Now we are going to find the difference between these consecutive f of x values, which will be delta f of x, again i.e. delta f of x. Again we are going to take the difference and we continue the process till we get single values of delta f of x. Now we apply the Newton forward difference formula, which is given as follow. For f of a plus uh is equal to f of a plus u by 1 factorial delta f of a plus u minus 1 u into u minus 1 divided by 2 factorial delta square f of a, and so on. Here h is the difference between two data. After putting the values, we get the resultant value 278.73. After rounding off, we will get the value 280. So the number of students who scored below 48 marks is 280. In case 1, the student who secured more than 48 but not more than 50 marks are 27, and the students who secured less than 48 but not less than 45 marks are 27. Part C. Write the algorithm for Lagrange's inverse interpolation. First, read number of inputs and second, read the value of x. Third, for I is equal to 0 to I is equal to n minus 1, read xi yi. Fourth, set sum is equal to 0, 5. For I is equal to 0 to I, n is equal to n minus 1, I is equal to n minus 1. Set product is equal to 1. For j is equal to 0 to j is equal to n minus 1. If I is not equal to j, then product is equal to product star y minus yi divided by yi minus yj. Then sum is equal to sum plus xi star product. Then we'll print the sum. Question number 4th A. Evaluate the integrate 1 by 1 plus x squared dx from 0 to 1 using the 3 point Gauss quadrature formula for the given abscissa and weight. We have data which is T1 is equal to 0.77459667, T2 is equal to 0, T3 is equal to minus T1, and W1 is equal to minus 0.55556, and W2 is equal to 0.8889, W3 is equal to W1. Let a is equal to 0 and b is equal to 1, then x is equal to b minus a by 2 multiplied by t plus b of b plus a divided by 2. Putting the values of a and b I, x is equal to 1 plus t by 2 and d by differentiate this we substituting the value of x and d of x in the f of x. Then function of t is equal to integrate 2 by 4 plus 1 plus t star 2 dt from minus 1 to 1. F of t is equal to 0.555556 f minus 0.7745 plus f of 0.7745 plus 0.88889 f of o. Integrate 2 by 4 plus 1 plus t star 2 dt from minus 1 to 1 is equal to 0.78527. So the value we'll get is 0.78527. Part B. Derive Simpson's rule using Newton's Cotes formula. Simpson's rule is numerical integration method that approximates the definite integral of a function using quadratic polynomial. It can be derived from Newton-Cotes formula, which are a family of numerical integration formulas that approximate the integral of a function using equally spaced points. Let's start by considering the interval a, b and dividing it into subinterval of equal width h. The points where we will evaluate the function are a plus h, a plus 2h and so on till b minus h and b, which gives us total of n plus 1 equally spaced points, where n is the number of subintervals. The general form of Newton-Cotes formula for equally spaced point is um, integration in the range of a and b f of x dx is equal to h star w o star f of x0 plus w1 star f of x1 plus w2 star f of x2 and so on. Here star is the multiplication operation where x0 is equal to a, x1 is equal to a plus 1 and x2 is equal to a plus 2h, till xn is equal to b and w0, w1, wt to the wn are the weights associated with the corresponding function's values. For Simpson's rule, we consider n to be even. In this case, we divide the interval a b into n by two subintervals, with each subinterval having a width of 2h. The points where we evaluate the function are a plus 2h, a plus 4h, until the b minus 2h and b, giving us a total of n by 2 plus 1 equally spaced points. Now we need to determine the weights W0, W1 and W2 uh, and so on for Simpson's rule. For Simpson's rule, the weights of the Newton-Cotes formula are given by W0 is equal to W2, W4 and till the Wn minus 2 which is 2 by 3. W1 is equal to W3 equal to W5 till the Wn minus 1 is 4 by 3 and Wn is equal to 1 by 3. Substituting these weights into the Newton-Cotes formula, we get integration in the range a b function f of x dx is equal to h by 3 star 2 by 3 star f of a plus 4 by 3 star f of a plus h plus 2 by 3 star f of a plus 2h plus 4 by 3 star f of a plus 3h till the 4 by 3 star f of b minus h plus 2 by 3 star b f of b. Simplifying the expression, we obtain Simpson's rule. Integration of function f of x dx in the range a b is equal to h by 3 star f of a plus 4 f of a plus h 2 f a plus 2h 4 f a plus 3h till 2 f b minus 2h plus 4 f b minus h plus 4b. Part C. Write an algorithm to evaluate Vidal's rule for the 6 points. First, read start. Second, read end. Third, h is equal to end minus start by 6. Fourth, for I is equal to 0 to I equal to 6, I read by I. And 5, s is equal to 0.3h, y0 plus 5 y1 plus y2 plus 6 y3 plus y4 plus 5 y5 plus y6, then print the s. Question number 5, Part A. Write the algorithm for the Runge-Kutta fourth order expression. First, define f of x and y, then return the expression. Read starting, ending, and split. Third, h is equal to ending minus starting by split. Fourth, while starting is less than equal to ending, if k1 is equal to h star f of xy, k2 is equal to h star f of x plus h by 2 and y plus k1 by 2, and k3 is equal to h star f of x plus h divided by 2 y plus k2 by 2, and k4 is equal to h star f of x plus h by comma y plus k3. X is equal to x plus h, starting is equal to starting plus h. Then the y will be y equal to k1 plus 2k2 plus 2k3 plus k4 divided by 6. Then we'll print the value of x and y. Part B. Apply predicted character method to solve d by dx y minus xy and y0 is equal to 1 in steps of 0.1 up to y0.2. Y to the power p n plus 2 is equal to y n plus 2h f of x n plus 1 and y n plus 1. Y to the power c n plus 1 is equal to y n plus h by 2 f of x n minus comma y n plus f of x n plus 1 and y n plus 1. By Hume's method, k1 is equal to f of xi by I and k2 is equal to f of xi plus h by 2 yi plus k1 h by 2. Here k is run count of character method. K is equal to k1 plus k2 by 2 yi plus 1 is equal to yi plus kh. Hence y of 0.1 is equal to 0.99975. Here P is for predictor and C is for character. Y of 0.2 is equal to y of 0 plus 2h f of x 0.1 and y 0.1. By predicted method, we'll get the value of y of 0.2 is equal to 0.98005, and by corrected method, we'll get the value of y of 0.2 is 0.982712. We can apply corrected formula again for accurate value by putting this corrected value as predicted value in the corrected formula. Part C. Apply the least square principle to fit a parabola in the given data sets. Develop an algorithm for this best fit parabola. Um, Algorithm is to fit a parabola to given set of data using the least squares principle. We can follow these steps. First, gather the data. Collect the data points xi, yi from the given problems or data set. Step 2. Define the model. We assume the equation of a parabola y is equal to ax square plus bx plus c, where a, b, and c are the coefficients to be determined. Step 3. Set up the system of equations. For each data point xi, yi, we have axi square plus bxi plus c is equal to yi. Rearrange the equation to axi square plus bxi and yi minus c. Step 4. Apply the least squares principle. Square each equation and sum them up over all data points. Summation of axi square plus bxi whole square is equal to summation of yi minus c whole square. Expand the equations and express it in terms of the coefficient a, b, and c. Summation of a square star xi to the power 4 plus 2ab star xi to the power 3 plus b square plus 2ac star xi to the power 2 and 2bc star xi plus c square is equal to summation of a yi square minus 2 yic plus c square. Step 5. Solve the system of equation. Express the above equation as the system of linear equation in term of coefficients a, b and c. Solve the system of equation using standard methods such as matrix operation or Gaussian elimination. Step 6. Calculate the best fit parabola. Once the coefficient a, b and c are determined, the best fit parabola equation obtained y is equal to ax squared plus bx plus c. Thank you. That's it for the video.